addition and subtraction formulas. Let's go and zoom on in. So here we have the addition and subtraction formulas. So here we have sine of s plus t equals sine of s cosine t plus cosine s sine of t, and sine of s minus t is equal to sine of s cosine t cosine s minus t. Another way you might have seen this is that you'll see a plus minus here and then a plus minus here. So if it was plus here, it's plus. If it was minus, it was minus, and then you'll see what they call a plus minus here, and then a minus plus here. That means if this was plus, that's minus is plus. And so sometimes you'll see it written that way. Because we can do the same thing with cosine. Cosine of s plus t is cosine s cosine t minus sine s sine t. And then it'll be cosine s cosine t plus if it's minus here. And so you just swap it. You can do the same thing here. Here's the tangent. So tangent of s plus t is tangent of s plus tangent t minus 1 tangent s tangent t. And then here if it's positive, negative, it's negative up top and positive down below. Okay, so I'm going to be using these to solve problems, and we're going to work on more identity stuff. We're going to do all this stuff. So we're just going to add these to the toolkit, and then go ahead and do some more stuff. So find the exact value without using a calculator. So can we do this without a calculator? And the answer is yes. So let's show how to do this. And so what do we have here? So here I have cosine of 75. But do I know cosine of two angles which equals 75? Sure. Because I know that 30 degrees plus 45 degrees, and these are angles that we should have memorized. We may not, but you should have memorized the same thing as cosine of 75. So here I'm just write cosine of 30 degrees plus cosine of 45 degrees. Same thing as cosine of 75 degrees. Then we're going to go ahead and use this formula right here. So I'll leave that right there on the screen. So we'll have cosine of 30 degrees cosine of 45 degrees plus, oh, sorry, cosine's the opposite, so minus sine of 30 degrees sine of 45 degrees. And so here I'll have square root 3 over 3. Oh, square root 3 over 2, sorry. Here we'll have square root 2 over 2. Here we have 1 over 2. And then here we have square root 2 over 2. And so if I add this all up, I'm going to get square root 3 times square root of 2, which is the square root of 6. Minus the square root, let me not write it there, so I have room to do the other one. So this will give you square root of 6 over 4. This minus the quantity of square root of 2 all over 4. And there you go. So here's the exact value of cosine of 75. And how we did that is we just split this up. Here I have pi over 12. Can I think of something that adds up to be pi over 12? And here, it's like, well, how am I going to do that? Well, if you kind of mess around in your mind for a little bit, if I had 3 pi over 12 minus 2 pi over 12, that gives me 1 pi over 12. Well, here, that's the same thing as cosine of, well, 3 pi over 12 is pi over 4, right? Which we can do, minus pi over 6, which we can also do. And so here I'll have cosine of pi over 4, cosine of pi over 6, plus, since it's minus here, it'll be plus here, sine of pi over 4, plus sine of pi over 6. And so here I get square root of 2 over 2, I get square root of 3 over 2, I get square root of 2 over 2, and then 1/2, basically the same numbers we had last time. But in this case, I'll be adding them. And when I add them, I'll get square root of 6. Square root of 6 plus square root of 2 all over 4. So here we can use this to find precise values without using a calculator. You'll have a calculator for those who are taking this during the COVID-19 remote requirement, or if you're online. And so, but get used to doing it by hand. Try it by hand a couple times before you instantly default to using a calculator. Alright, so we want to find the exact value of this expression. So here we took a number and broke it apart. Here we're going to take a broken apart number and put it back together. So here, notice that this expression is the exact same as this. And so this is just kind of getting you used to looking at this. So here I have sine, cosine plus cosine, sine. Here I have sine, cosine plus cosine, sine. So this is just the same thing as sine of 20 degrees plus 40 degrees, which is the sine of 60 degrees, which is square root of 3 over 2. And where did I get this from? So I noticed that this is sine cosine plus a cosine sine of the same angle, and then you just realize that that is just the addition formula. Now, how do you recognize that? You just work on these problems enough, you'll just get used to seeing it. It's kind of like learning a foreign language, like the first time you learn what sit is in the foreign language and you learn 5 other words and then you come back, what was sit? You're like, oh, I don't remember, right? Same thing with this, is like, well, you see this, you do it a couple times, like, okay, I got it. You go do something else, you come back, this, oh, I forgot what this is. But as long as you know to look at your, honestly, for these sections, I would have, for chapter 7, I would just have a big, huge list of formulas that I have just printed out somewhere and just say, hi, here's all the formulas. Which ones just look like that one, and try to mess with it. Kind of what I would do. Alright, so prove this identity. So now we've gone from just kind of simplifying stuff to proving identity. So here I have the addition, or cosine add and subtracting, so I'm subtracting. So here this will be cosine of pi over 2 cosine of x plus sine of pi over 2 sine of x. And where do I get that from? Right here. Oops, actually, I'll be using this one. And so I'm just pulling that. And then I pull this out, do this across. And so here I'm working on the right-hand side, because that's definitely the more complicated one. I mean, the left-hand side is a single number. Cosine of pi over 2 is 0. So this ends up all being 0. Sine of pi over 2 is 1. So this just ends up being sine of x. So this is sine of x, which equals my left-hand side. So I'm done. Okay, so the first couple will be relatively simple like this, and you can just kind of plumb through it, and then it'll get relatively more difficult as it goes along. And I do say relative. Some people are gonna, some people breeze through this and they really like the puzzles, and some people just can't stand it. Just cannot stand the puzzle part of all of this. So you'll get through it. So let's do this one. So here, notice here that I'm going to start with my right-hand side. Right-hand side. And I have a tangent of an angle plus an angle. Well, do I know what that is? Yeah, it's this. So here would be tan plus tan minus tan, tan. Alright, so let's do that. Please be very careful where the S's go and the T's go. I'll be doing it for you for now, but you'll eventually have to do it yourself. And so here we have u. We've been using u as our thing, so here will be the tangent of the first one, which is pi over 4, plus tangent of u, all over 1 minus tangent of the first one, which is pi over 4, tangent of u. But notice that tangent of pi over 4 is 1, and this is 1, so this simplifies to be 1 plus tangent u over 1 minus tangent of u, which is equal to my left hand side. So here I've proven it. Or yeah, so I made my right hand side, done stuff on the left hand side. So I'm working kind of the other direction. Alright. At this point, I do want to do a problem that I did not type in the notes, and so this comes up on the exams, it comes up in the homework, and I just didn't write it. So here is a problem that looks like this. It'll say find sine of theta plus phi. You do not have to write this up for points when you turn in the notes to me. Unless I'm reusing these videos and I've added it to the notes, then yes. but currently, just make sure I want to make sure I've gone through this with you once. And so let's just say sine of theta is equal to 12/13, and this is in quadrant 2. And then let me write this a little bit more clearly. With theta in quadrant 2, and then tangent of phi is equal to 3/4 with phi in quadrant 3. Okay. So what does that mean? So what we want to do with this information is I want to find this. Well, how am I going to find this? I need to find out what. So let's go ahead and translate that. Let's translate that real quick. But I'm going to leave me some space because I want space. No, I don't need space. I can work here. So this, if I just use the formula, would be sine of theta cosine of phi plus cosine theta sine of phi. I'm like, okay, so which one of these do I know? Well, I know this one, right? That one's given to me. It's 12/13. Do I know what any of these other ones are at the current point? No. But can I figure it out? Yes. And so if I'm in quadrant 2, my triangle should open this way, right? Notice here, if I have my circle, triangles in quadrant 1 will look like this, quadrant 2 will look like this, quadrant 3 will look like this, and quadrant 4 will look like this. And the reason I draw them in the proper orientation, that reminds me to make the correct signs on everything. Because here, if this is my theta, and it's in quadrant 2, I'll have 12, which is my y, which is positive. My hypotenuse is always positive, and so I want to figure out what this is, right? And so it would be the square root of 13 squared minus 12 squared, which is equal to the square root of 25, which is equal to 5. But notice, since I'm in quadrant 2, that's important, my x value here would be negative, so it'll be minus 5. So here, I can figure out what this is. So it'd be adjacent over hypotenuse, which is minus 5/13. Okay. Now here, I get phi, so I'm going to open up this triangle in the correct direction, is equal to 3/4. But notice here, since we're in quadrant 3, I know that, and this is my phi, right? I'm in quadrant 3. Here, I know that this will be, since I'm in quadrant 3, it's really negative over negative. And so it's opposite over adjacent for tangent. And so it'll be negative 3 over this. And then to find this, I'm just going to take 3 squared, or negative 3 squared plus negative 4 squared, and take the square root. And that gives me to be, once again, this is square root of 25, which is equal to 5. And these are very popular triangles for these problems, the 12/13/5 triangle and the 3/4/5 triangle. So, but now I can figure out what the rest of this is. So here, cosine of phi is opposite over, or adjacent over hypotenuse, so this would be minus 4/5. And then here, for this one, it would be opposite over hypotenuse, so it would be minus 3/5. And then notice we add these up. Let me finish the problem. So if I just add this up, so notice here I'll get 65 on the bottom. And so we'll just write 65 here, and then I just used a calculator. I'm not going to lie. I just used a calculator just to crunch through this number. Look at this. So we have negative 33/65. Now, once again, how do we solve this? So we see these, and when they'll give us two triangles. They always, for this type of problem, they'll say sine is something like this, and one of the trig functions is something, one of the trig functions is something, and I'll tell you what quadrant it is, and that's important. From there, you know two sides of a triangle. And depending on the quadrant number, you'll know you can solve for the other side of the quadrant and the other triangle. So given two sides of a triangle, you can always find the third, right? Because these are all right triangles. These are all right triangles. And so you can just use Pythagorean theorem. So if you know the hypotenuse and a side, you can figure out the other side. You know two sides, you can figure out the hypotenuse. Then you're going to figure out, depending on what quadrant is remember in quadrant 2, x is negative and y is positive. Remember in quadrant 3, both x and y are negative. And so just make sure you label it correctly. And using which way this triangle. So here, this is a triangle in quadrant 1. Here's a triangle in quadrant 3, right? And then you can have ones in quadrant 2 and 4. And so just be careful with that. You'll do this once or twice and then it'll come together. So I just wanted to show you an example because I forgot to do it in the notes. All right, so let's get back to the notes and let's do a couple more of these. So let's look at this. So show, oops, I want to do it here. Whoop, whoop. All right, so let f of x equal to some function. I'll get back. And here we just want to find the difference formula for sine of x. And we want to show that equals this mess. And you're thinking, holy smack, that's going to be hard to do. And it's not the easiest thing to do in the world, but look at there. So let's just start. Let's just start with the left-hand side. So the left-hand side is where all the actions happen. So left. And so f of x, so this would be sine of x plus h minus sine of x all over h. Okay, so now we have x plus h. We know how to split that up. So it'll be sine of x cosine h plus cosine x sine of h minus sine of x all over h. Alright, so notice what I can do here is there I have cosine, sine, and so I'm just going to rearrange this a little bit. Let me rearrange it before I do anything. Let's see. I want to explain it to you so you don't get lost. So I have sine of x cosine h minus sine of x plus cosine x sine of h. Now what if I did? All I did is move this over. Here I have a sine of x and sine of x, so I can pull that out. So I can have sine of x, oops, I forgot, all over h. So sine of x over cosine of h minus 1. So here I'm just pulling the sine of x out here, so I moved it over and pulled it out. Cosine x plus sine h all over h. And notice here that this is this, right? This is that. Let me just rewrite it real quick. Let me just write the right hand. No, let me just give me a little bit more room. So here I'll have sine of x cosine h minus 1 over h. Notice that this equals that because here I can split the fraction here. Plus cosine x sine of h over h. And this is equal to the right hand side. So we're done. Alright, so here we just plug it in. We split our addition here, and then we just collect like terms, so the sine of x's are all right here. We factor it out, and then we recognize that this is this, and we just make it look like that. All right. Okay, get rid of this real quick. Let's go up. So we want to express x, so express in terms of x and y. This is another popular problem for the homework and the exams. The department loves asking this one because it makes it see if can you really do this. And so let's look at this. And so here I have given sine of something and something where x is between 1 and negative 1. That just makes sure that this works out, right? And y is any number. What is expressed this in terms of x and y? Well, the inverse cosine of x is just, this is remember the inverse cosine gives back an angle, so we're just going to call that theta. This gives back an angle, we're going to call that phi. Okay? So let's look at this real quick. Let's just draw us two triangles. So here I have theta, and that gives me x over 1, right? So the inverse of x over 1 gives me that. So here, My adjacent would be x, my hypotenuse would be 1. And how do I get that? Because inverse cosine, let me see if I can write this out just a little bit. I mean, cosine of theta equals x over 1 is the same thing as saying the inverse cosine inverse of x over 1 is equal to theta. Right, that's what it means to be an inverse. So cosine theta equals x over 1, so that's adjacent and hypotenuse, right? And then here I have two parts of a right triangle. I can figure out what this is. It's just 1 minus x squared, right? Hypotenuse minus the side. Alright, so we can do the same thing here. So tangent, here we just said it's y. So here I have, let me go ahead and let me see if I can do this, try to get you as least loss as possible. So y over 1 equals phi. So here, so I'm saying that this is equal to some theta, this is equal to some phi. I don't know, I just want two angles, right? So tangent of equals phi, or the inverse tangent of y over 1 is equal, oh, hold on, let me write this. I have that backwards. I was like, why is this not making sense? Because you have it backwards. So tangent of theta equals y over 1 is the same thing as the inverse tangent of y over 1 equals theta. And if you don't see the 1 over here, you can just always write 1 over 1. Now, why would I want to write that? Well, it's opposite over adjacent, so here I have y, here I have 1, here therefore the hypotenuse is 1 plus y squared. And this is my angle of y. Oh, this is my angle phi. So here, I have sine of phi, sine of theta. So here I'm just going to split that up. So this will be sine of theta cosine phi, because here I have an angle plus an angle, plus cosine theta sine phi. Well, do I know what sine of that sine theta is? Yeah, just come here to theta. So sine theta would be 1 over 1 minus x squared over 1. So that's just 1 minus, oops, square root of 1 minus x squared. Cosine of phi, well, the cosine of phi is over here. It'll just be 1 over y plus 1. Square root, or 1, square root of 1 plus y squared. Didn't even say that close. Plus cosine of theta will be x over 1. So this is just x. And sine of phi would be y over this. So it would be y over 1 plus y squared. Okay. Notice we have the same denominator. We can just add up the top, so we'll have 1 minus x squared for this side plus xy on this side over 1 plus y squared, take the square root. And so this is how you answer this one. This one seems really complicated, but after you do like 2 or 3 of them on your own, it tends to fall out to be something a lot simpler. Alright, so let's do the very last page of this. Alright. So here, if a and b are real numbers, and we have a sine of x plus b cosine of x, we can write this as case of x plus phi. And so notice that you recognize how to write this as your, and you know how to graph this. And so what's k? Well, k is the square root of a squared plus b squared, and phi satisfies these two equations. And see, that's something easier explained. Something easier explained than shown. So let's do that. So here, if I have 3 sine of x plus 4 cosine of x is the forms k plus x plus pi. So we want to write this, we're going to take something in this form and write it in this form. So what we need to do, we need to figure out what k. Well, k is the square root of a plus b squared, which in this case is the square root of 3 squared plus 4 squared, so this is 5. And so we have k is equal to 5. Then we have cosine of phi is equal to 3/5. So 3a and then a plus, which is the same thing as k, right? This is, you can also write a over k, b over k, okay? You can write both of them, okay? So here we have a over k, b over k, so we have sine of cosine of phi, and then sine of 4/5. And notice here that this just gives us the triangle, which is the 3, 4, 5 triangle for your phi. Hold on, that should be a phi. And so the angle for phi, this angle, which I know from physics because we use this triangle all the time, is 31.1 degrees. Can you just solve for it? Sure, right? There's 1,000 ways to solve it. You can just use your inverse function. You can use inverse sine, inverse cosine, inverse tangent. But the reason you need both the sine and cosine, because I will tell you which quadrant it is in, right? Because if both of them are positive, it's in quadrant 1. If sine is positive or cosine is negative, you're in quadrant 2. If they're both negative, you're in quadrant 3. And if cosine is negative, or cosine is positive and sine is negative, you're in quadrant 4. And so it's important that you do both because you have to figure out what quadrant you're in. So you can't just, so you'll be able to just take the inverse, but then you'll have to translate into which quadrant you are in. Okay. All right, let's just kind of quickly touch on this very last one. And so let's do one more problem this real quick, so just get used to it. So here we have 2x. Well, do I have 2x here? No, so we're going to take this x and we're just going to pretend it's 2x for a second, right? So you can do this for any size. And so here the k is still the same. K is equal to the square root of a, which would be -1 squared, plus b, which is square root 3 squared, which is 1 plus 1 plus 3, which is equal to square root of 4, which is equal to 2. So that's where we're at there. So here our k is 2. So we want to solve where the sine of, so notice here, so we sine, I might have made a small boo-boo. Notice a goes on the cosine, so this should be, no, I did it right. This is 3, this is 4. The cosine goes here. Oh boy. I did not make a boo-boo. So notice you switch ones, so here it's negative, so here will be square root 3. Sine will be square root 3 over 2, and sine of phi equals square root 3 over 2, and cosine of theta equals -1 over 2. So this tells me cosine is negative, sine is positive, so that tells me I'm in quadrant 2. And so here I'm just going to take the inverse cosine, because that will give me the correct, that will produce a quadrant 2 number. I plug that through a calculator, or just do it in my head, or however you want to figure it out. And that's going to produce that phi is equal to 2 pi over 3. And so here we can write this out. And so here I have, oops, I never finished this, did I? Let me write this in the form. So this is equal to 5 sine of x plus 53.1 degrees. Here we're going to do this one in radians. And so this is equal to, so all this is equal to 2, because that's what my k is, sine of 2x plus 2 pi over 3. And then notice from here, in order to graph it, if I wanted to graph the function, it'd be 2 sine of 2x plus pi over 3. And then here we can just briefly graph it. I'll just sketch it real quick just as a reminder. So here, the plus means I go back pi over 3. And so, and here it's sine, so it starts at 0 here. I'm going to go up to 2. I'm going to go down to -2. Notice here, my period would be pi, so it would be, my period here is, this is 2, so it would be 2 pi over 2, which is just pi, so I'll move pi distance this way. So pi minus pi over 3 is 2 pi over 3. And then halfway between would be pi over 3. Hold on. Nope, hold on. Let me make sure I'm doing this correctly. So let me go slowly so I don't mess up. So pi over 3, 2 pi over 3 is 1 pi distance. Half of that would be, just put the halfway mark, and then the fourth marks. I can do this. Half of pi would be pi over 4. No, pi over 2, so pi over 2 minus pi over 3 gives me pi over 6. There we go. Pi over 6 is where this will cross through, so it comes up, comes back down, at pi over 6 comes up and goes through. Okay, and so that's just one period, and we can just go from there. Alright, so that's the end of these notes. Good luck and take care, and have fun.